Ben McCown, hydraulic master here. What we're going to do today is show when you have a tractor and it doesn't want to go forward or backwards, or it doesn't want to spin the blade properly, what's involved and how to fix it. Right there is the back end of one of the two pumps that's in a Vermeer tractor, and the Ditch Witch RT80 is very much the same. They have two pumps, and this is what their two pumps look like in an RT80. They're almost exactly the same. Ditch Witch has an auxiliary pump out here on the front that provides what's called the charge pressure to keep the rest of this hydrostatic transmissions in the case of a ground drive. But what they really are is they are a hydraulic pump that can reverse the flow and then can vary the flow. So one of these drives the wheels and the other one drives the attachment. They work the same way. Hydrostatic and variable displacement pumps are frequently of this design, and we're going to show you how it does its magic. I think this is really cool. So you want to be able to show the pistons?
Yeah, I got to take this off first.
Okay, and we'll show you what breaks in these things. Yeah. And you can fix it yourself. You don't need to spend $7,000-8,000 and go buy one from the dealer. Okay. These pumps are made by Danfoss. They are sometimes available on eBay.
Wouldn't count on it though.
Wouldn't count on it.
The exact same part number.
Yeah. And there's a part in these that keeps failing, and they keep improving it, and it keeps failing. And you know, every time they come up with a part, they have a rev number on the part, and we're up to rev number I don't know what on the new yoke. Do you know what it is? Okay.
But this here, you got to make sure you mark it and then count your revolutions when you take it apart, so you can put it back together the exact same way.
Okay.
So that is important.
There's one.
I've already counted.
Oh, you've already counted them.
I've already counted. I know it. So
okay.
I've written it down on top, so we can put it back
together. And this is the preload on the spring and the centering. Is that what this is?
I think this is mechanical stop for the servo control.
Okay. Inside of it. All right. And don't be afraid to open these things up.
Unless your machine's under warranty.
Well, okay.
And you care about that.
Yeah, just don't tell anybody. All right. There have been some micro trenching blades, not ours, that have had large gullets that are prone to snagging. And a blade that comes to a screeching halt repeatedly can cause this one part to break in these pumps. And it got so bad that at one point, our local Ditch Witch service manager said, we're not going to honor the warranty on these anymore if you're using this brand of micro trench blades. Now, that manufacturer of micro trench blades has long since fixed this problem, okay? But you can break a weak part in this pump if you bring a micro trenching blade to a screeching halt. Now, this is a really fun mechanism. All right, this is a swash plate pump. And if you notice, it's got a whole bunch of pistons. Oh, you're really going to take it apart.
Yeah. So don't lose anything.
Okay. So you see those pistons? That they're oops, sliding out.
A little bit.
Okay, they're what actually pumps the fluid through the system.
Operates like that.
Okay, operates like that if this plate right here is doing the wobbly thing. Okay. Now, the only two places I know of that use swash plates are swash plate pumps and helicopter hubs that control the flapping of the blades. Because on a helicopter, when the blade advances, it needs to be at a flatter pitch than when it's retreating, due to the fact that the wind's blowing at it when you're going forward, and when the blade comes around the other side of the helicopter, the wind's chasing it. So you got to have a different angle to have the same amount of lift on both sides of the helicopter and roll over. So let's just show everybody what controls how that swashing action works, and what happens when you go from forward to reverse in one of these. You want to put it back together, or what do you want to do?
I will put it back together, but you'll see here. Yeah.
All right. This is the part that fails. This is another part that fails. Frequently, they break off here somewhere, and this is what controls the swashing. This forces those pistons to basically follow the prescribed path that you want for the correct direction of flow and the correct amount of flow. So let's reassemble it here. Oh, you can see it broke right this time. Now the one we fixed that one time, we actually totally repaired one of these.
Had the same failure.
It was the same failure at the same place.
Yep.
Because I remember we
drilled this out. We put a pin,
and then we
cross drilled and welded it.
Didn't we use silver brazing?
We might have brazed
and induction heating. Yeah.
I think we did.
But that was kind of an emergency repair. I would not recommend doing it. Buy the new one.
Oh, 327 and nope, 327. Yeah, same part number on that side.
A B.
This one here is R824B1. This is R80462.
Anyway, they've changed. We've pulled several of these out over the years, and the new part we get always has a more a part number that has an advance in one of the digits or one of the letters or something. So anyway, there's the pistons, there's the cylinders. All right. Now, if you look at where they rub up against these ports right here. This is where the input or the output of the cylinder. Can you flip the cylinder over there so you can see it? You see, that's the cylinder. These are the ports. Now, some of these ports, like the top ports here, would be like for forward, and the bottom would be for reverse. So you get your direction of flow depending on if the oil's coming out of or going into those pistons. Now, the magic of that is the swash plate. And Ben's going to hopefully reassemble the swash plate and yoke here so you can see how that works. It's so cool. I just love the way these things. I wonder who did the first one. He was pretty clever dude, whoever it was. But this is the part that you're going to have to replace when it breaks, and it won't go forward, won't go back, won't go anywhere, or only goes forward or only goes back, or
it spins at just a slow speed all the time.
Yeah, it spins at one single speed in one direction all the time. Well, you can kind of see the action there. You can set it down. Okay, so all right. Now, if you twist it one way, now this thing's spinning, right?
Yeah, this whole thing is spinning.
Okay, so those pistons are spinning around. Now, let's see, does the cylinder spin too? Yeah, I think it has to, doesn't it? Yeah, it does. Okay, so let's say this is the top of the pump, and let's say the oil going to the wheels to drive forward is coming out here. All right, when this whole set of pistons and cylinders come around, like if they're in that position, they're squeezing the oil out of the cylinder to go out that discharge port to the wheels driving forward. Now, if you twist it, if you go like this and you put it right in the middle, as it spins, the pistons aren't going up or down. I don't know if you can demonstrate that or not, but and if you go like this, then the pistons are fully depressed on the backside when it's spinning around, and they're pumping all the oil out the other port. So this is the swash plate. I don't think going this way, it's kind of restricted. It can't move this way, right? No. So it only moves this way and this way, okay? And this is engaging, where's the yoke thingy? Oh, this engages this. Let's stick this in here. Can we get it in there?
Yeah, just take some hand movement here.
Big hammer.
Nope.
Okay, you got that? Now this goes side to side under hydraulic pressure to, well, this is held. Yeah, it's held. And then this yoke thing, it's got springs there, but it goes side to side under hydraulic pressure. Now, these pistons here are what actually moves it, and it's in these cups that he unscrewed these cups earlier. Okay, but that's not the whole story. So there's the miniature little hydraulic cylinders that control the swash plate. But the fluid control to those little cylinders is this block assembly. Yep. And what you have here
I've taken the springs out.
Okay. So this controls, what does this engage?
This engages this horn.
And the horn's in there. So
the horn thread's in there.
Okay.
That
What? So
these two fingers, they're supposed to have a spring on there.
Oh, that gives it the feedback. Okay. And what it does is it directs oil to these pistons, but it only directs it if these solenoids here on the end are pulling this valve back and forth.
These ones have a manual control, so you can see that little thing in the middle. That's all they're moving.
They're moving just an eighth of an inch or so, and that's all the movement to go all the way forward, all the way reverse, and all points in between, or is 0 to max speed on the blade. Now these solenoids are not just a normal electromagnet. Okay, they're designed to be pulsed, and what the controllers are doing is they're sending out a square wave to these solenoids that has a variable amount of length. So it might be just tiny little spikes if you're just trying to move the machine forward really slow. If you want to go max speed, then it just the square wave is just on all the time. So it's the gap between the waves in the square wave. It's called pulse width modulation, and that's what you put into these things, and that's what they send the oil to those pistons. A little feedback loop here. But so you have a controller on the machine that's sending out the pulses to these solenoids. Does this have foot pedal?
Yes.
So this and an RT80 both have foot pedal. So that foot pedal has an encoder, and it tells a computer its position. That encoder, the computer then says, oh, he's pushed it down a little bit here. He wants to go forward, obviously. It sends out a signal over the data bus, the CAN bus, that's connecting everything together in these machines. And that bit of information goes to this motion control thing. Motion control says, oh, pedal's been pushed a little bit. I need to make a little bit of a pulse going to, say, this solenoid so he can move forward. And he only pushed it down a little bit, so I'm just going to send out a little spiky pulse and wait, another spiky pulse and wait. And what those spiky pulses do is they put a little bit of pull on the magnet, the electromagnet. And so it's a variable amount of pull. That's why they call it electroproportional control valve. And so that pulls here. This checks the feedback little finger there, and it puts a little bit of pressure into this piston, which then moves the swash plate a little bit, and then it can tell that it moved, and so it stops it from going too far. It's a pretty cool system, but it's simple. You can see these parts, there's not that many of them. Easy to put together, easy to take apart. Do you use any gasket sealer on this?
Nope, they're steel seals. So
steel seals.
I think you're technically supposed to replace the seals.
Probably, but
manual on Dan
we've done this a lot.
That tells you exactly what to do.
And Danfoss has got a really good manual on if you want to do a factory test of this thing. There's all kinds of gauges and things. But we found that, hey, just tear it apart and say, whoops. I think that this thing was probably supposed to be stuck to that thing. And say, okay, let's get us a new one and put it back together and see if it'll work. And I think you'll be really happy when you do it. So there we go. Ben McCown Technology. We get bored easy.